Path of the Pole by Charles Hapgood, Part 6. You are listening to Brothers of the Serpent podcast.
Let's do it.
And welcome back, ladies and gentlemen, boys and girls, angels and demons and monsters and serpents. This is Brothers of the Serpent podcast, and we are coming to you not live from the 10 by 10 by 10 tangent cube of science, where we are nestled amongst the dusty bones of an ancient seabed high atop the Edwards Plateau. I saw somebody, there was some comment that was like, let's see, high atop the Edwards Plateau, does that mean in Texas? And tangent cube means in somebody's basement? It's not a basement.
I don't know if I haven't seen many basements in Texas.
Yeah, there's not a whole lot of basements. Okay. We should open this. We got some 1-up boxes, and we should open these before we start the show because we got ourselves
a globe.
A globe from Jeff of Books.
A miniature
lover
expanded
of books
flat earth.
and boobs from the Discord. Oh, yes, nice. It is a ballooned flat earth.
Yes. Very nice. Thank you, buddy. Oh, that's cool how it rotates on there. I like that.
So now Kyle doesn't have to remember to run in the house and get the globe.
This thing is cool.
And what was the other thing we sent? I went to the P.O. box to pick this up, and there was something else in there. This one was like sent to Kyle specifically, I think.
Someone sent me the Mysterious Cities of Gold.
Looks like an animated
series.
Complete animated series, yeah.
Perhaps anime.
We don't know who it was from.
Program content. Copyright 1982. I mean, Virgil Films. This, I just like when I looked at this, I was like, this reminds me of Superbook.
Superbook, yeah.
And it looks pretty cool. I bet Soul's gonna dig it.
Oh yeah,
I'll probably dig it.
Yeah.
So thank you for, I guess, Patrick.
Was it Patrick? Yeah, that's what it looked like to me. It said Patrick was the.
Thank you very much. I will definitely check this out with the kiddos. Maybe I'll watch it first because I don't know about you people.
Watch this with your kids.
I'm just kidding.
Okay.
Thank you all very much.
Yeah. So we're
Man,
still
it's the countdown.
Path of the Pole, Part 6.
We're leaving to Egypt in a week.
Yeah. We're prepping for Egypt. And remember I was saying, you know, the deeper we get into the book reports, the more people sort of like
just kind of start bailing.
Yeah.
Yeah.
So like all you Part 6ers, you guys are the deep divers. Appreciate you sticking around. But yeah, I mean, it's weird. I don't see that happen too much on the podcast, the actual RSS feed, but on YouTube, people start bailing. Oh yeah. You know,
the tubers.
Yep. The tubers can't take the book reports.
Can't handle it.
But there are plenty left. I'm just saying, you Part 6ers are great for sticking around.
We're getting shadow banned. I'm pretty sure.
Could be.
That's the classic excuse if your numbers aren't up as high as you think they should be. Oh, yeah. It's totally obvious we're being shadow banned.
So last week we ended with Hapgood making the point that if the most recent glaciation had very short periods in it, you know, the warm and cold periods on a matter of like 2,000 years or 3,000 years long, then it doesn't really make a lot of sense to think that all of the older glaciations really
were hundreds
of thousands of years long. So he says, if there is any doubt as to the reasonableness of dismissing these estimates, it should be put to rest by an entirely new estimate of the glacial chronology produced by Emiliani. Emiliani, working with Marine Corps and applying some of the new techniques of dating, has found that the earliest Pleistocene glaciation occurred only 300,000 years ago, and that all the 4 recognized European glaciations and their alleged American counterparts have to be compressed into that comparatively short period. This finding, which there is no good reason to reject, completes our picture. It disposes, finally, it seems to me, of the traditional glacial chronology of the Pleistocene. As a consequence of this breakdown of the old theory, it seems to me that we must now start from the beginning and build a new glacial chronology of the Pleistocene. Our method can only be the tested method of science, to proceed from the known to the unknown, from the Wisconsin glaciation, where our information is most ample, backward. Okay, the beginning of the Wisconsin Ice Age. First of all, I shall have to jump the gun by suggesting that the North Pole was in the ocean north of Norway, approximately in latitude 72 degrees north, longitude 10 degrees east, from about 75,000 until about 50,000 years ago. A good deal of the research work, which has indicated this location for the pole at this time, was carried out by Professor T.Y.H. Ma. So you remember this guy was the guy that did all the Chinese guy that did all the work on corals.
Yeah.
Ma? Yes, Professor Ma of the University of Taiwan. Okay, maybe is he Chinese? I don't know. To whom I am much indebted. Some general reasons for suggesting this location are: 1. The last ice age appears to have started a great deal earlier in Europe than in America. Some of the European geologists call their later ice age, contemporary with the Wisconsin glaciation, Worm 2, and the earlier, heavier glaciation, Worm 1. 2. While this earlier European glaciation, Worm 1, was in progress, America seems to have enjoyed a long, warm period called the Sangamon Interglacial. A glacial period in Europe simultaneous with a very warm period in America can be well explained by a pole in this position. The evidence for all this will be presented in detail in the following pages. It is all the more important to discuss the evidence fully because American geologists are, at present, all convinced, on theoretical grounds, that the American glaciation extends back as far as the European. They are, in fact, so convinced of this that they have not looked for the evidence bearing on this question. They expect that, when they get around to it, they will find evidence of glaciation in America between 40,000 and 80,000 years ago. I have news for them, however, they will not find it.
Wow. Strong.
3. The transition between Worm 1 and Worm 2 in Europe was a much greater change than those fluctuations of climate that are called interstadials. The evidence of radiocarbon tests show that at the end of Worm 1, a vast ice cap of great thickness retreated from England and the Irish Sea and never returned. In some respects, its history parallels that of the Wisconsin Glacier. We shall return to this question a little later. So what do you think about this? So this is a prediction he was basically making in the 70s, in the mid or late 70s, about they will not find evidence of a glaciation in America between 40 and 80,000 years ago. I looked it up and looked at a bunch of different graphs of the ice amounts. There was ice, but it wasn't expanding at this time, I don't think. But I would be glad to hear if anybody else has any different information on that.
What was the deal about Norway? He was saying the pole was just north of Norway?
Yeah, so
at this time? So it's closer into Europe?
So yeah.
This is during the European glaciation period or whatever. He's thinking that they don't coincide.
Between 75 and 50,000 years ago, the North Pole was in the ocean north of Norway at approximately 72 degrees north, 10 degrees east.
This thing, I don't see any numbers on these lines, but that would be like the Norwegian Sea or something.
Yeah, so that would make a lot of Europe be in the Arctic Circle.
There's all this. There would be so they would be in an ice age.
Yes,
in Europe. Right. And then the U.S. and Canada would not be.
Right.
Some of Greenland would.
Yeah.
Greenland would be in the Arctic Circle, probably.
It's also interesting how he says this you know, how often we come across this and just in other scientific disciplines is this idea where he says, American geologists are at present all convinced on theoretical grounds that the American glaciation extends back as far as the European, and they are in fact so convinced of this that they have not looked for evidence bearing on this question.
Right. Yeah. Yeah.
They assume that it's true, so they don't see it as a question. And he says they expect that when they get around to it, they will find evidence. Okay. The birth of the ice cap. I have already cited a statement of Coleman's, quoting Lowe, to the effect that the central area occupied by the Wisconsin ice sheet now shows few signs of having been glaciated at all. The pre-glacial debris in the central area is largely undisturbed, while a broad circle around it is scoured clean to the solid rock. This fact is actually of very great significance. It is, or might be, one of the great unsolved mysteries of the Pleistocene glacial period mentioned by Daly. It seems that the ice cap did not start in a small area and expand outward, but rather it started all at once over a great area. It deepened until it became thick enough to move by gravity, and then the edges of the ice cap, in contact with the ground, were set in motion by the pressure of the ice behind them and began their scouring action, striating the bedrock of the continent over which the ice cap expanded. This suggests indeed a rapid transit of the pole from its assumed position in the Greenland Sea. It was fast enough so that the ice cap did not start growing at the coast and move inland. It started in the Hudson Bay region, and after it had grown thick enough to move, it spread outward in all directions. A very remarkable evidence of the suddenness with which the ice cap was born is the fact that it contained thousands and perhaps millions of animals of a temperate climate, many of them frozen entire into the ice, including mastodons, mammoth, bear, elk, beaver, and so forth. When the ice cap melted, many of these animals were dropped into bogs, which preserved their bodies and sometimes even the contents of their stomachs. It is evident enough from the assemblage of species that the snow overwhelmed them while they were living in temperate conditions. What this may mean is actually rather frightening to contemplate. The ice sheet had to grow to a thickness of several hundred feet before it began to move. Then it began its long journey, advancing century after century until finally it reached the limit of its expansion in the Ohio Valley to the south. It seems to have entered Ohio for the first time about 43,000 years ago. Simultaneously, we have radiocarbon evidence of the expansion of mountain glaciers on the Pacific coasts. After this, the ice cap seems to have gone on growing until its climax with the Tazewell Advance about 17,000 years ago. The whole development of the ice cap, then, seems to have required between 30 and 40,000 years. This is exceedingly interesting considering its very abrupt departure. An ice cap that may have taken as much as 40,000 years to develop disappears for the most part in 2000. It must be obvious that this could not have been the result of gradually acting climatic factors, usually called upon to explain ice ages. With such factors, the ice retreat would be at about the same tempo as the advance. But what factor could have produced melting at a rate 20 times faster than accumulation, except such a basic factor as a polar shift? Considering the indicated speeds of the polar shifts, it is surprising that there was an acceleration of the rate of erosion, or is it surprising that there was an acceleration of the rate of erosion and accumulation of sediments at the end of the Ice Age? So again here, speaking from 50 years in the future, we do have another possible explanation besides pole shift for this rapid melting.
Right, but it doesn't explain the extent of the ice south.
That's right. It doesn't. You're right. It doesn't explain the placement of the cap.
Yeah.
And the extent of it. Yeah, I agree. But I'm just saying with the melting by itself.
Yeah, for sure. Yeah.
Okay. Dating.
Is there any objection to the idea from the standard model? Because I know there's the energy paradox and all that stuff. So when someone suggests an impact could have caused the meltdown, they say, well, where's the crater? But is there actually an objection to, well, if there was an impact, could it have caused this? I haven't actually heard that specifically discussed on the standard model side.
Yeah, that's a good question. I don't know. I don't think so. I mean, I don't think so, but I don't know.
Are they basic with their question of where's the crater? Are they basically saying like it would have to have been so big that we couldn't have missed it? Is that what they're saying? Because they don't elaborate.
Yeah.
It's just simply like, where's the crater?
Right. I don't know. I can't speculate on their reasons for asking that question.
But yeah, so you haven't heard any.
No, I haven't. To me, it just seems like a cop-out, but that's just how I feel.
That's what, yeah.
That's what I thought. But again, I don't know. But those are good questions. Like, are they basically saying the only way that this could have caused all this melting was if we had an enormous impact and we should see a crater, and there isn't one, therefore it didn't happen.
Right.
Which is why you were making the point a couple of episodes back about how important it is to stress that it's a bombardment of fragments. In other words, you can have the same amount or
of
even
energy,
greater energy input without having an enormous crater. Yeah,
absolutely.
Yeah,
because the other thing is, and I guess we probably already talked about this, but the pole shift doesn't really explain all of the rare earth metals and proxies and incredibly high temperatures and stuff like that.
Yeah, you mean like in the
YDB layer?
Yeah, in the boundary
black
layer.
mat. Yeah. It doesn't explain, the fires and everything burned and all this. Unless you're just talking about volcanism, but that doesn't explain the metals,
right? Or the spherules or the nanodiamonds. Right.
Yeah.
Yeah. But again, the other thing we have to keep in mind is that the whole comet impact theory is for the beginning of the Younger Dryas, meltwater pulse 1A. There is no explanation for the end of
1B.
it. Or 1B.
Yeah, 1A is 14,000.
Yeah, okay.
There isn't.
There's not a meltwater pulse at the end of the Younger Dryas.
I don't know. I think there is, but it's not named 1C, I don't think. I don't know.
Meltwater pulse 0. Right. So what I'm saying is that the end of the Younger Dryas isn't explained, and that was a big melt-off as well, a massive climate change.
Yeah.
But if you go with Hapgood's explanation of this shift, I don't know if this can explain it either. It seems too rapid. Well, I don't know, maybe 2,000 years, 10,000 BC to 8,000 BC. That's when 8,000 BC is when the hypsothermal, the climatic optimum begins, right? So that's possible. Okay, dating the polar shift. Radiocarbon evidence has established the occurrence of a warm period in Europe between the two phases of the Ice Age, Worm 1 and Worm 2. This is called the Gottweg interstadial and lasted about 50,000 to about 43,000 years ago. In our view, this warming of the climate marked the departure of the pole from the Greenland Sea. In a way, it was not an interstadial at all. Its length itself suggests that it had a different cause. In any case, we interpret it as a climatic improvement resulting from the fact that the pole had moved from just north of Norway to distant America.
Okay, so the Greenland Sea is where it is, which is just north of the Norwegian Sea.
So it may be recalled that at the last presumed displacement of the crust, at the end of the Ice Age, the polar shift was indicated by the Brady interstadial, which evidently was, like the Gottweg phase, not really an interstadial. The two periods were similar in being caused, it would seem, not by intervals between volcanic upheavals, but by two different polar shifts. They were similar in that they were comparatively long. the Gottweg lasting about 7,000 years and the Brady about 3,000. They were followed by colder periods, the Gottweg by a cold phase that lasted about 3,000 years, and the Brady by the Carey Advance that lasted 1,500 years. It seems that the proportions were maintained. The cold phase after the Gottweg was followed by the Hengelo interstadial, which lasted 2,000 years, while the Carey Advance was followed by the Two Creeks interstadial that lasted about 1,000 years. There seems to be a suggestion here of a repetitive pattern, but the evidence is as yet insufficient for definite conclusions. So it's interesting what he's doing there is comparing these things that are happening in Europe versus what's happening in the States. That's what the different names are. The Gottweg and the Brady. Brady happened in the States or in the Americas, while the Gottweg was the European one. And what you see is in Europe, when there's supposed to be an advance of ice, there's an interstadial in the Americas.
Yeah. All right.
And it goes back and forth and back and forth.
1,000 to 2,000 years at a time or something.
Right. Well, and the ones that are happening in Europe are all longer, and they're longer than the American ones by roughly the same proportion for each. So you got 7,000 and 3,000 years, and then 3,000 and 1,500 years, and then 2,000 and 1,000 years. It's like they're roughly the same, almost the American thing is half as long as the European one each time, even though they seem to be going back and forth. It's weird. I wonder if this Carey Advance is the Younger Dryas. Lasted about 1,500 years.
Let's see. How's it spelled?
Cary. Carey. Okay. The Irish sea ice sheet that invaded England about 55,000 years ago was very thick. It filled the Irish Sea basin and was thick enough to sweep across the ridges of the Welsh mountains. Forrest describes the glacial evidence of this ice sheet that entered England from the northwest. He feels that so massive an ice sheet had to originate on a land mass larger than Ireland, and therefore supposes that there was then such a landmass in the North Atlantic. His views have been opposed by geologists, but it now appears that Soviet geologists have been led by other evidence to suppose the same thing. Did you find it?
No. Not yet.
Okay. So this is interesting. The Irish sea ice invaded England 55,000 years ago and crossed the mountains. That must have been a massive ice sheet. So to reconstruct the chronology of the previous shift of the pole, it is necessary to go back a stage earlier to the time when the pole arrived in the Greenland Sea. Evidence of this still earlier shift will be presented below. But here I want to mention merely the fact that it occurred, so far as we can see, between 80 and 75,000 years ago. If we are correct, the chronology then is as follows. By 75,000 years ago, glacial conditions had begun in Europe, and a great ice sheet formed, perhaps on a land bridge connecting the British Isles with Iceland and Greenland. After a few thousand years, it had grown thick enough to move out from the center of thickest accumulation by gravity. It covered Ireland, filled the Irish Sea basin, and swept across the Welsh mountains into England about 55,000 years ago. Its advance, it appears, required a period of 20,000 to 25,000 years, comparable to the time that was apparently required for the growth of the Wisconsin ice sheet. We have just noted evidence suggesting that a polar shift occurred at about the time this ice sheet reached its maximum, the shift from the Greenland Sea to Hudson Bay. So it is easy to connect the two events. The shift brought the advance to an end and initiated the glacial retreat. This retreat probably started long before 42,000 years ago, and by about 37,000 years ago, the ice sheet had left the Irish Sea basin. The decline of the Irish Sea ice sheet seems to have required a period of time similar to the time required for the decline of the Wisconsin ice sheet. The parallel is extremely interesting. It cannot be claimed that events of this magnitude are comparable to the minor fluctuations that we have termed interstadials. So what happened in America? We have just seen that between 55,000 and 43,000 years ago, there was a vast improvement in the climate in Europe with the disappearance of the Irish Sea ice sheet. That is not easy to say.
Irish Sea ice sheet. Irish Sea ice sheet.
Exactly the opposite thing happened in America as the Wisconsin ice sheet entered on its vast expansion. So again, he's pointing out here that that right when ice is retreating in Europe, you see it growing massively in the Americas on the other side of the planet.
So the first thing I think of is like these big ocean currents or, jet streams and those sort of like develop and create some kind of stable system. And then sometimes they change. Right?
Yeah. So
we have really short period ones.
Right. So for a long time, it's carrying super cold air over to Europe, and there's this massive advance of ice, and then something happens and it changes, and then it's bringing it over.
Yeah. So you're seeing a cyclical pattern.
Yeah.
But it's, is it possible that it's more weather related in terms of ocean currents and jet streams and that kind of stuff? Because you can imagine like thinking of it as this system. Of course, the currents and the winds on the planet they develop into a sort of a repeating pattern, but the Earth is also going through cosmological cycles, and so they can have an effect on the Earth's currents and stuff. So I that's what I think of as an alternative. It doesn't have to be that the crust is shifting around. It could be that there are these longer, 10, 20,000 year shifts that it's kind of like oscillating back and forth between two fairly similar patterns. But why? I'm not offering any solutions.
And then there's the axial nod, right? It goes up and down, but that's only a few degrees. It doesn't do much.
Milankovitch cycles.
Then there's the Milankovitch cycles. Yeah. So Hapgood has kind of listed those off and said these aren't. There's not enough. There's no evidence that these are enough to cause what we're seeing. But I mean, a lot of people think they are enough, or at least that there's some kind of explanation. It is a placeholder at least for these cyclical things. But I do think that his point about, first of all, the
like, what if we're just passing through, let's say there's some kind of think of a spiral dust pattern or maybe some kind of like thick dust or material in space that's in bands that we're passing through.
Yeah.
So we enter this regime of like all this dust. So then everything just gets hotter. Like the entire solar system gets hotter. Because the whole solar system is hauling ass through all this dust.
Oh, okay. I was like, wait a minute. The dust blocks the sunlight, so everything should get colder. But maybe you're right. Maybe,
no, I'm just thinking of
because we're running into it.
Yeah.
Okay.
Like the sun's running into it as well.
Yeah.
So the sun would get hotter.
Wow, that might set the sun on fire. That could be dangerous.
Oh my God. Get a sun extinguisher.
Yeah, okay. But then you would think we would see evidence that there would be it would be banded in layers of the sediments, right? That there would be these periods where you're like, look at all this interstellar dust. And every 40,000 years, there's a layer of this stuff for a couple of thousand years. And maybe there is. If no one is looking for it, then they're not going to find it.
That would be tough because it'd be spread out over periods of like 20,000 years.
Yeah. I mean, they find nanodiamonds.
Yeah, but it would basically be part of the background abundance, right? For that period of 20,000 years.
Yeah. But you should see that there's like an increased amount of it and then a decreased amount if we're going through bands. If they've looked, right? That's the question. Is like, is that something you would notice when you weren't looking for it? Or do you have to really look like with the nanodiamonds? Like you have to really do a serious process to even find it. Yeah.
Anyway, it's just a harebrained idea.
No,
I'm just trying to think of other
possible causes. This is the other thing. It doesn't explain why it's going back, and that wouldn't explain why it's going back and forth across the planet. Like America's warmer and Europe is cold.
I'm talking about something that's driving the changes in
the climate,
in the like ocean circulation currents and like I don't know. Yeah. Like if you heat it up a little bit, is it going to severely alter all these currents? I don't know. Yeah, I really don't know.
Okay. So it is believed by most geologists that the Ice Age began at the same time in Europe and America and followed the same course in both continents down to the final establishment of the present climate. Since in Europe, an early part of the Ice Age apparently began between 80 and 70,000 years ago, the same is assumed for the Americas. But there is not the slightest evidence that glacial conditions existed in America prior to about 55,000 years ago. On the contrary, the evidence is that James Bay, practically in the very center of the area that was to be glaciated by the Wisconsin ice cap, was ice-free 53,000 years ago. Secondly, the dates suggest that the climate changed in opposite directions in Europe and America. In Europe, between 50 and 37,000 years ago, a gigantic ice sheet that had covered Ireland, the Irish Sea, Wales, and half of England melted away, while in America, the Wisconsin ice sheet was expanding rapidly. By 30,000 years ago, the latter had invaded the United States and stimulated the growth of glaciers on the Pacific coast. It continued to expand rapidly through the Farmdale and Tazewell advances, while, on the other hand, in Europe, the Scandinavian ice sheet was comparatively thin, and in England, glaciation was mostly confined to mountain glaciers. It is time that these discrepancies were taken account of. I present a theory that can reconcile the facts. It is unfortunate that the theory makes so complete a break with accepted ideas. Nevertheless, the truth, if it is the truth, must eventually be faced.
It really is a good explanation. I mean,
we don't have to face it though. You can run from the truth your whole life.
Yeah, it's a good one. I mean,
yeah, and
I don't know why it would oscillate back and forth like that, but that is really strange. That like try to come up with some
explanation for why there would
be this big patch here and then it vanishes and then one appears over there and then back and forth when it's like, why? Number one, why is it even that far south?
Mm-hmm.
That's weird. They should if it was a global cooling event, they should appear at the same time and disappear at the same time.
Yeah, that's right.
Because they're like literally in the same latitude.
Yeah. Kyle's getting good use out of this.
Oh, I love this globe, dude.
Yeah.
It's like, I can really...
Maybe we can write some numbers on there.
I was thinking about getting a pin out and drawing the path of the pole on this globe.
Yeah, there you go. Okay. That's a good stopping point. Let's take a break.
Okay. Shadow Band! I'm saying. I've made up my mind. Welcome back to Shadow Band.
Shadow Band of the Serpent.
That's right. That's actually a good band name, Shadow Band.
It is. Oh, yeah. That's a great band.
Anyways, I love this path of the pole stuff. It gets me. I was really in a food coma when I got in here. Just ate a big dinner. I was just like, oh man. But yeah, just 30 minutes in, I'm just like ready to checking out this globe. It's getting my brain going.
That's
bro.
the sound of the globe. In case
This is so when you rotate it on the. It's very.
So if you hear that, you know that Kyle is spinning the globe.
But yeah, it gets my brain going, man.
Good.
The body's shutting down, the brain is turning on.
Yeah, and I was gonna say because we ended the last segment and you were talking about. Well, not at the end, but you were talking about how there are other maybe possible explanations, but I don't know. I've obviously had to read forward through this book. And when you get to the mountain building stuff, it really starts to get, because that's a whole other, just leave the ice ages behind and let's look at other possibilities. So
Teaser.
yeah.
Maybe I'll have other ideas about those.
You probably will. I'm hoping we're going to get there today. Like
I can't help it. I have
see.
to. I have to explore ideas.
No.
But so far, I'm still really like, yeah, this is a really good idea.
Yeah, it's a good possible explanation. Okay.
And there's no really good argument to say this can't happen.
Right.
Right, other than a bunch of conjecture as well, right?
Yeah,
like to say that it can't happen, and like giving reasons why it couldn't happen would also be a bunch of guesswork.
And I think it's also eye-opening how many renowned geologists from the past he's dug up that already thought this took place. He's mentioned multiple times like that these guys were going through their field, whatever their specialty was in geology, and some of them would come to the conclusion that the only way to explain this is by crustal shift. Some of them were like, the only way to explain this is by expanding Earth. So it isn't like that this is a totally novel idea.
Right.
So one of the ways that I think people discount it now is that they just think there are better, less drastic explanations for some of these things. And Hapgood is, I think what he's saying is like, well, if you take all of these geological mysteries, then you can have one explanation for all of them.
Yeah, so it's more simple in a way.
And yes, and it's comprehensive. So yeah, if you were going to use, Occam's razor.
It's simple in a way, but to explain the process of the actual crust shifting as a whole is complex. I mean,
right.
This is, so it's, but in a way it is simple.
Yeah. But it's like, how do you, this is the thing about Occam's razor that I dislike so much is like, who decides which one is the simplest?
Yeah.
And it's really about the fewest assumptions, I think. So, for example, like one of the things I think of is the complex theory explanation for the Carolina Bays, right? This guy's like, no, like some kind of air burst over the continent is like, that's not it. Let's come up with this 4-part complicated theory to explain it.
Custards, latrines.
Right. Customers, latrines, yeah.
Aioli. What else is in there?
So I'm just saying, it's like, which one is the simplest explanation?
Yeah. I think the cosmic one is more simple.
Right.
But it lacks sufficient evidence. Not in the
you're right.
In the geomorphology, but the proxies, like what we should expect to find.
Yeah.
Doesn't seem to be there. Now maybe it was a strange impactor that just didn't have, maybe it was a big ball of limestone from some other ocean planet.
Yeah.
I don't know.
Yeah. So that's what I'm saying. I think people are, with the crustal shift stuff, it's the same kind of thing. It's like, well, we can explain this by using either a global cooling or a global warming for glacial periods and interstadials, that are...
Seems simple.
Yeah, that seems simple, but that's complicated weather.
Right, which is already complicated. That's the point. It's like either way you go, you can argue it, but it's a bunch of guesswork.
Yes, that's right. And that's why I think that, just in general, I would say that you can't say that there are better explanations. I think that this is just, this is...
I like this one.
Yeah. Okay. The Yukon district at the pole. The logic of the facts we have marshaled to support the assumptions of two different positions of the North Pole prior to its present location leads us to postulate a third. It is known that, prior to about 75,000 years ago, the North Atlantic was warm. The warm Eemian interglacial climate prevailed in Europe. For this, there has to be a reason, though none has been convincingly presented for it. We are compelled by logic to assume there must have been a still earlier shift of the lithosphere about that time. We have been compelled to look for the most logical site the pole may have occupied before it was located in the Greenland Sea. The site we have selected as an assumption for further scientific testing is the Yukon District of Canada. The two greatest advantages of this assumption are that it can explain both the Eemian interglacial in Europe and a preceding ice age in North America, which geologists have named the Illinoisian glaciation. We note that here again, Europe and America would have opposite climates. We assume that during the period of the Greenland Sea pole, Europe was very cold, while America enjoyed the Sangamon interglacial. With the Yukon pole, there was a reversal, and while lions and hippopotami enjoyed a warm European climate, the bitter cold of the Illinoisian Ice Age gripped the United States. Okay, skipping a whole bunch of stuff here. Actually, the entire end of this chapter because it's a bunch of cores.
Okay, so the Yukon district is right on the border of Alaska.
Okay. Okay, chapter 8. Polar change in the remote past. In the previous chapters, I have reviewed the evidence for 3 displacements of the Earth's crust during the last 110,000 years. They seem to have occurred at intervals of 30 to 40,000 years. There are indications that they may have occurred at this rate through much of the Pleistocene epoch. From the evidence we now have, it seems futile to try to determine the locations of the poles in the more remote cases. With every step backward in time, the evidence naturally becomes thinner. Eventually, perhaps, we may know more. At present, however, there are other matters to be considered. We must consider whether the rate of geological change suggested for the last 110,000 years by the evidence presented in this book can be typical for the entire history of the Earth. It is plain from the cores that rapid change has characterized the record for the Pleistocene. Radiocarbon dating has established the fact that all of the geological processes of glacial growth and decay, precipitation and sedimentation were accelerated during the Wisconsin Ice Age. Emiliani has argued, as already mentioned, that all the ice ages of the Pleistocene occurred in the last 300,000 years, which implies a threefold increase in the velocity of geological change as compared with the older views. Studies of the delta of the Mississippi River suggest numerous important changes at short intervals. Blanchard has shown that there were at least 12 major climatic changes in the valley of the Somme since the first glaciation, accompanied by changes in sea levels, fauna and flora, and human cultures. He argues that only polar change can explain this record. So there's another one. For the older geological periods, There are a number of lines of evidence that suggest rapid change. So insistently, indeed, does this theme occur in the strata that Brooks, in his Climate Through the Ages, refers to a 21,000-year cycle of climatic change. Think about that. He's getting 21,000 years, but it's pretty close to precessional.
Yeah, 2,160. Yes.
Yeah, I was thinking if you just make it 26,000, it's basically a full cycle.
Oh, yeah. 21,000, not
Yeah.
2,100. Yeah.
Right. So he believes there was a 21,000-year cycle of climatic change, which he believes operated through the whole Eocene period, or for about 15 million years. His figure, of course, is only a rough average, and the intervals may have been very unequal in length. With reference to a still older period, he remarks, alternations in the Cretaceous of USA suggest a cycle that is estimated at 21,000 years, but there are no annual layers. Irregularities in the cycle are indicated by another study of Eocene beds covering about 5 million to 8 million years. In this case, annual varves were present, and they indicated long-term changes at 23,000 and 50,000 years. Some scientists have attempted to explain these cycles as the result of the Earth's astronomical precession. But in view of the above-mentioned irregularities, the phenomena seem better explained in terms of crust displacements. So that's the next thing I started when I was reading this. I started thinking of, precession is a wobble, and is it going to add to the possibility that a crustal displacement would take place? Would it add stresses?
Yeah, I don't
Motion. Once it gets to a certain point, is there a breaking point?
Or is it always the same speed?
Yeah.
Can it accelerate and decelerate?
Right.
I don't know.
And does crustal shift itself have an effect on that at all? Is it going to cause the planet to slow down in its rotation at all, or speed up maybe?
The thing I keep thinking about is the, asymmetry of the ice cap.
Yeah.
Right? Causing the stress to pull it off of the pole.
Yeah.
But if that were the case, and if that was the main driver, it would seem that the direction of the drift of the polar wandering would always be close or relatively close to the same direction. Because let's say you get this off-center ice cap, and so it drags itself towards the equator, right? It drags the crust in that direction to pull that ice cap further out towards the equator.
Mm-hmm.
Then while that cap is melting, a new one is forming.
Yeah.
But now you still have this offset weight over to that side that it just drifted away from.
You mean the old ice cap?
The old ice cap is still there off to one side.
Yeah.
So there's more weight over there, and now you're building a new one. So it would seem like it would just keep dragging in that same direction, not go back the other direction, which is what he's saying. It's like it's shifted this way, then it came back, and then it went. So I what I'm saying is that if this is actually what is happening, then I don't think it's going to be caused by an imbalance caused by the ice. It doesn't seem to be.
Yeah. Yeah, and I think that
because it seems like it would just never stop.
Yeah, I see what you're saying. But if that ice moves towards the equator and then it melts off in a couple of thousand years, meanwhile you need a couple thousand years for the other one to build up, then that ice has been distributed throughout the water system.
Yeah.
And then the next direction it takes is wherever the new cap has an extension.
Right, that goes for
and that would be random based on land masses and whatever.
The new pattern of the climate and all that. So if it had enough time, it's just
But I still think that you're right, that it probably isn't the
that
biggest driver.
Like the main driver.
Right, the biggest driver probably isn't an imbalance of the ice, because there's the isostatic response sort of compensates for that. It sinks into the planet and sort of equalizes, right?
Yeah. The other thing I was thinking about was those two giant blobs
Yeah.
way down inside there. Like, what are they doing? They're offsetting the mass of the Earth in some weird way.
Yeah.
I don't know.
It's possible that an impact could cause.
That's another thing for sure.
So do we have cyclical impact events, and those cause crustal shifts?
Well, that's kind of what Randall's been getting at too. Is that that like this is possibly a cyclical thing that we go through, and Graham has also talked about that,
Right.
and that's why the ancient people are always warning of the second coming
Yeah.
from heaven.
Yeah, and the Egyptians are like, well, it's like the 8th or 9th.
Yeah.
You guys don't remember.
Egypt is really just like in a pretty safe spot, surrounded by so much landmass.
Yeah, when are they going to have their pole period? That's,
That was the other thing that's been going around too. And my brain is like, if this has happened, then surely the pole has been, where the equator is now.
Yes. I mean, we read about this in the earlier episodes about people studying glacial periods in southern India and Africa.
Okay, yeah, I forgot about that.
Yeah, and the guy's like, I'm sitting here sweating in the sun, picking up evidence of a massive amount of, like it's hard to
Glaciers.
imagine that there was 2 miles of ice on top of this
that
spot.
doesn't make any sense.
Yeah.
Come on.
And that the ice flowed
I'm
north.
buying it.
The ice flowed north from those spots. In other words, that it started there,
But
Purchased. Okay. So naturally, such frequent changes in climate have had profound effects on the formation of sedimentary rocks, one consequence perhaps being the thinness of the individual strata. Very seldom can deposits be found that indicate with any certainty the uninterrupted deposition of more than a few thousand years. On the other hand, innumerable cases of conditions interrupted after a few thousand years can be proved. In addition to the evidence mentioned above, Brooks, for example, Brooks should be an expert in small streams.
yes,
But I don't think that's what he is. Brooks, for example, refers to a great salt lake or inland sea that existed in Europe in the Permian period and says, the number of annual layers indicates that the salt lake existed for some 10,000 years, after which the salt deposits were covered by a layer of desert sand. Wallace, too, refers to the evidence of sudden changes in climate at short intervals in his Island Life. Quote, the numerous changes in the fossil remains from bed to bed, only a few feet and sometimes a few inches apart. Some of the best evidence is provided by coal seams, which are ordinarily thin and interlayered with rock, indicating very different climatic conditions. There has developed a considerable literature on the rate of coal formation, and some recent experimentation has thrown light upon it. Kroll devoted considerable attention to this problem. He estimated that it would take about 5,000 years for the formation of 1 yard, or about a meter, of coal, and came to the conclusion that the periods of coal formation between changes in climate were about 10,000 years long. It is obvious that any changes that replaced conditions required for coal formation by conditions suitable for the formation of sedimentary deposits beneath the sea, for Kroll points out that rock strata between the coal strata are usually of marine origin, were indeed radical changes taking place in short periods of time. So, in other words, if you take that at face value, you have 5,000 years to develop a yard or a meter of peat for coal formation, or a yard of coal, which is a lot of peat. It's probably 10 times that much peat. So you have a bog or something. And then that whole thing needs to be covered in an ocean for 10,000 years of deposition of marine sediments. And then it goes back to where it was before, and then you have another coal seam above it, and this oscillates back and forth. That's what this guy seems to be saying.
So again, well, yeah, that's like 15,000 year cycle.
Yeah.
How does he know that?
So these were radical changes taking place in short periods of time. Another writer, Otto Stutzer, after a very careful calculation, concluded that a Pittsburgh coal bed 7 feet thick could have formed in no more than 2,100 years. In view of all this evidence, we must not be too much impressed by the very thick layers of rock that are occasionally found. Kroll, who was a sound geologist, even if his theory about ice ages was not accepted, pointed out that the thickness of a deposit will depend upon a great many circumstances, such as whether the deposition took place near to land or far away in the deep recesses of the ocean, whether it occurred at the mouth of a great river or along the seashore, or at a time when the sea bottom was rising, subsiding, or remaining stationary. Stratified formation 10,000 feet in thickness, for example, may, under some conditions, have been formed in as many years, while under other conditions it may have required as many centuries. So he's basically saying stratified formation 10,000 feet in thickness may have formed in 10,000 years or 10,000 centuries, depending on the conditions. So it is worth noting that at a number of points, the evidence for great and frequent changes in the Earth's climatic conditions is linked with evidence of structural changes in the Earth's crust. That is, with changes in the elevation of lands and in the distribution of land and sea. Kroll remarked, "It is worthy of notice that the stratified beds between the coal seams are of marine and not of lacustrine origin. If, for example, there are 6 coal seams, one above the other, this proves that the land must have been at least 6 times below and 6 times above sea level." So, yeah, it's marine rather than lacustrine, meaning not lakes, right?
Yep.
Coleman has emphasized the frequent association of abrupt breaks in the continuity of the strata with extreme changes of elevation above or below sea level. In discussing the Permo-Carboniferous period in India, he says, "There are the usual cold climate fern leaves in these beds, and above them, without an apparent break, come the Productus limestones with marine fossils." So I wonder if these discontinuities, I'm just wondering if some of these discontinuities have to do with there was an erosive period that erased a bunch of strata first. Then you get, you still have to have ocean and land, if the sea has to come in and then go away.
Yeah.
But during something that catastrophic, you'd probably lose material. I don't know.
Yeah, I see what you're saying. Like there could be an erosive event.
Yeah.
But then you should have big deposits of gravel and stuff like that in there too.
That's true. But it just seems like if you have a coal bed and then above that is marine sediment, there's like a discontinuity there somewhere. There was obviously a change period.
Right.
Okay. Now, it seems altogether reasonable to suppose that if changes of climate were associated with changes of elevation in these different kinds of cases, then the two may have occurred at the same tempo and have proceeded from the same cause. The hypothesis of periodical shifts of the Earth's crust provides both the link and the cause. An interesting study of repeating geological cycles in a very remote period has been completed by Weller. He deals with the so-called Pennsylvanian period several hundred million years ago, which had a span of between 35 and 50 million years. He points out that in the study of this period, numerous examples have been observed of the deposition of different kinds of sedimentary beds in the same order at irregular intervals of time. The changes in the composition of the beds imply changes both in climate and in the elevation of the seas above sea level, in the elevation of the areas above sea level. The cycles are not just local, but can be traced over wide areas. Furthermore, each complete cycle represents an advance, retreat, and re-advance of the sea. Weller accounts for the cycles by diastrophism, that is, by some sort of upheaval in the Earth, some activity within the Earth's body, but he is not able to specify its nature. He recognizes about 42 cycles during this period, with each cycle having a duration of about 400,000 years. So, yeah, this is interesting. Again, he's pointing at, so this is away from coal beds. You just have all these different kinds of sedimentary beds. Let's just say for sake of example, there's 4 different kinds. And that cycle occurs over and over and over again. It repeats in the same order. These 4, these different kinds of depositions.
Yeah, that's really strange.
So these cycles would appear at first glance to be considerably longer than those that might result from crust displacements. However, there are a number of factors that tend to lessen the apparent difference between them. First, Weller points out that discontinuities in the deposits he is discussing are far more numerous than is generally supposed. This means that a part of the record is missing. Then, we must remember that a complete cycle involving the retreat and advance of the sea, probably in a number of stages, would call for several movements of the crust. At any one point on the Earth's surface, several movements might be required to bring the sea level to its lowest point, and several more to bring it to its highest point. Moreover, Weller points out that in each of his cycles, deposition has been interrupted twice, thus reducing the average length of the subdivision of the cycle to periods of the order of 75,000 to 250,000 years. But it must be remembered that we have only averages. The cycles differ greatly, and their subdivisions also differ greatly in length. When we consider the fact that the intervals and directions of crust displacements are necessarily irregular, there appears to be a very good agreement between our theory and the facts of the Pennsylvanian cycles. At least it will hardly be denied that the theory offers the first possibility of understanding the cycles. Moreover, if our recent experience of the shortening of our estimates of geological time in the Pleistocene is a valid basis for extrapolating to earlier periods, it may well be that Weller has attributed too great an average duration to his cycles. It appears, therefore, that crust displacements may have been occurring through the whole of one of the major subdivisions of the Paleozoic era. So I like that. Yeah, he points out that, okay, so this guy has found what looks like 42 cycles during a 35 to 50 million year long period, and each cycle has a duration of about 400,000 years, but that's an average, and he's saying the minimum is 75,000 years, and a better average might be 250,000 years. But he's pointing out that since the cycle encompasses the sea is there, then it's gone, and then it's back, that would take multiple crustal shifts to happen. So it is impossible in the present state of the evidence to say that displacements of the crust have been going on uninterruptedly all throughout geological history. It may be that there have been times of quiet. The important thing at the moment is that investigators should be willing to undertake further inquiry without preconceptions based on outmoded ideas of gradual change. Let us recall the following words of the greatest geologist of the second half of the 19th century, Edward Seuss. The enthusiasm with which the little polyp building up the coral reef and the raindrop hollowing out the stone have been contemplated has, I fear, introduced into the consideration of important questions concerning the history of the earth a certain element of geological quietism derived from the peaceable commonplaceness of everyday life, an element which by no means contributes to a just conception to those phenomena which have been and still are of the first consequence in fashioning the face of the earth. The convulsions which have affected certain parts of the earth's crust with a frequency far greater than was until recently supposed show clearly enough how one-sided this point of view is. The earthquakes of today are but faint reminiscences of those telluric movements to which the structure of almost every mountain range bears witness. Numerous examples of great mountain chains suggest by their structure the possibility, and even in some cases the probability, of the occasional intervention in the course of great geological eras of processes of episodal disturbances of such indescribable and overwhelming violence that the imagination refuses to follow the understanding and to complete the picture of which the outlines are furnished by observations of fact.
That's awesome right there, yeah.
Yeah, why was that so hard to read? This guy needs to restructure his sentences.
It's it reminds me of what it's like going through Arizona and and the Scablands and stuff, and looking at these gigantic features that are just ripped up, but they're so huge, enormous. You're just like you can't even imagine the violence of the processes that created them.
Yeah,
it's just, good stuff.
Yep.
Alrighty.
Let's take a break.
Next break.
Almost always wrong here at Brothers of the Serpent podcast. Maintaining our accuracy of, 99.7% wrong? Something like that in the last survey.
I thought it was getting better. I thought we were at like 98.6.
Getting more wrong? Oh, 98.6. Oh, yeah. Are we at body temperature wrongness?
It's easier to remember.
That's true. Almost always wrong, almost all of the time. That's the easiest way to say it. So yeah, during the break there, short break, we were just talking, I was just mentioning to Kyle, like the idea of entire mountain chains growing by a result of massive earthquake movements, like this guy was saying. It's just amazing to imagine. And, I think that in general, what he's talking about here is he's basically saying you can look around on the planet and see there's evidence all over the place that this idea of slow, gradual change all throughout geological history is just complete crap.
And more accurately, it looks like almost everything was created incredibly violently.
That's right. Yes. So Hapgood says the great work from which the foregoing statement was taken is entitled The Face of the Earth. The prospect that unfolds before us as we contemplate the possibility that total displacements of the Earth's crust have been a feature of geological history since the formation of the crust itself is nothing less than the discovery of the formative force of the shaping factor that has been responsible not only for ice ages, not only for the mountain ranges, but possibly for the very history of the continents and for all the principal features of the face of the earth. Chapter 9, The Shaping of Earth's Surface Features, Part 1, Mountains and Great Rifts. By far, the most magnificent features of the lithosphere are the lofty mountain ranges that are found on all the continents, exciting the wonder of man, and those other equally tremendous mountain ranges that lie drowned in the silent depths of the sea. These mountain ranges carry in their intricate formations much of the history of the lithosphere. If we could know the forces that produce them, we could grasp the basic dynamic principles of the Earth's development. Unfortunately, though the mountains have long been the subject of intensive scientific investigation, they have preserved their secrets well. The most important of these secrets is the secret of their birth. What forces within the earth were responsible for their formation? As of now, we do not know. Nothing could better betray the extent of our ignorance of the dynamic processes that have shaped the face of the Earth than this confession of ignorance. Yet it is agreed by geologists that no theory has so far satisfactorily explained mountain building. Daly, for example, has referred to the process of the folding of the rock strata, a phase of mountain building, as an utterly mysterious process. Gutenberg has concluded that none of the present theories will do. He remarks that all the forces discussed so far seem to be insufficient to produce the formation of mountains. And this includes, of course, the long exploded but still widely current theory that ascribes mountains to the cooling and shrinking of the Earth. Have you heard this one?
No.
As to this, Gutenberg remarks, other scientists have pointed out that the cooling of the Earth is not sufficient to produce the major part of the crumpling, especially since investigations of the radioactive heat which is produced inside the Earth have indicated that the cooling of the Earth is less than it had been originally believed. So yeah, this idea basically is the opposite of expanding Earth. So the Earth starts out as a big molten droplet.
Yeah, when it was really hot way, way, way back in time, it would have been bigger.
Yeah. And everything starts to cool down, and then you get a crust forming, and then the shrinkage causes the crust to buckle and make mountains. That's the idea.
Makes sense, yeah.
Bullard, reviewing the third edition of Harold Jeffrey's basic work, The Earth, notes the absence of progress towards solving the problem of mountain building since the second edition 37 years ago. Pearson and Schuert, the authors of a general text on geology, conclude a section on the cause of mountain building with the statement, "It must be admitted, therefore, that the cause of compressive deformation in the Earth's crust is one of the great mysteries of science and can be discussed only in a speculative way." More recently, P. Chadwick, after quoting a statement by F.D. Adams written in 1938 on the failure of attempts to solve the problem of mountain building, added, "Since these words were written, the Earth's surface features have been studied more intensively than ever before, and much thought has been given to the processes by which they have evolved. But a deeper understanding has brought with it an increased awareness of the extreme difficulty and complexity of the subject, and the possibility of a final solution appears, if anything, to have receded."
Basically what he's saying is, the more they learned, the less they knew.
Exactly. Exactly.
Classic Snake
It's
Bro.
easy to think you have the answer when you have no idea what's going on.
That's right.
So what is the nature of this problem that has so far baffled science? The problem of lithospheric folding. It is important to take into account the fact that there are several kinds of mountains and that their origins may be ascribed to somewhat different circumstances, even though, as we shall see, they may be related to one underlying cause. Some mountains are caused by volcanic eruptions. These consist of piles of volcanic matter. Some of the greatest mountains on Earth's surface are volcanic mountains. Many of them are found on ocean bottoms. And when they rise to the surface, they form the island chains, such as the Hawaiians, that are especially numerous in the Pacific. Sometimes, volcanic islands or mountains can be formed quickly, as was the case recently in Mexico, where a large cinder cone was developed in a few years to a height of several thousand feet from an eruption that started in a cornfield on level ground. Some mountains result from a vast flow of molten rock that gathers under the lithosphere at one spot and domes it up. The cause of these events are unknown. Many mountains, and even whole ranges of mountains, are brought into existence in part by the cracking of the Earth's lithosphere, accompanied by the tilting of the separated blocks. The Sierra Nevada mountains of California appear to have been formed in this way. According to Daly, they represent the tilting of a single block of the lithosphere some 600 miles long. Some folding of the lithosphere, however, had previously taken place. Many great chasms, extended cliff formations, and rift valleys appear to have been formed by the cracking and drawing apart of the lithosphere, and by the elevation or subsidence of different sides. The Great African Rift Valley is perhaps the best known example of this sort of formation. The rift of which it is a part, as we shall see below, has recently been connected with a worldwide system of great submarine rifts. The cause of all this cracking and tilting is still one of the mysteries of science.
So it's just like a huge crack formed in the plate, like it just pulled apart.
Yeah.
Golly.
It may be the top of a V-shaped crack.
Yeah.
Yeah.
Wow.
But yeah, there's the giant, it's sort of a legendary rift in Africa, but in Hapgood's time of writing this book, he's saying they recently discovered that it just keeps going throughout into the ocean.
Yeah.
It's part of a massive series of huge rifts. So the greatest mountain systems on the Earth's surface have been formed as the result of the lateral compression and folding of the lithosphere. Since folding is the cause of most mountain building, it must hold our particular attention. As already suggested, science is at a loss to explain the folding. A number of suggestions have been advanced, but they all, including the convection current hypothesis we have already mentioned, are deficient for various reasons. So the convection current is basically saying that you have enormous currents beneath the lithosphere pushing one plate into another one and making it. A part of the public is under the impression that mountains have been formed by the action of running water, wearing away the stone, eroding the tablelands, and depositing layers of sediment in the valleys and in the sea. Although it cannot be denied that erosion has been a powerful factor in shaping many mountains, and may have been the main factor in shaping some of them, for example, Mount Monadnock in New Hampshire, which I can see from my window as I write these words, it cannot have been the principal cause of the formation of our great folded mountain ranges. Geologists who have argued in favor of this theory have pointed out that the deposition of sediment in narrow lithospheric depressions may have been a cause of the folding of the lithosphere. The folding could have resulted in part from the sinking of the valley bottoms under the weight of the sediments. The process will be found described in detail in almost any textbook of geology. There are serious objections to it, and no geologist today considers it a satisfactory explanation. One objection is that this process of folding is essentially local. It cannot explain the greatest mountain systems, some of which virtually span the globe. It cannot explain, for example, the almost continuous line of mountain ranges that includes the Rockies, the Andes, and the Antarctic Mountains, and which extends for a total distance of almost half the circumference of the Earth. Neither can this theory explain the numerous submarine mountain ranges that have, in recent years, been discovered on the bottoms of the Atlantic, Pacific, and Arctic Oceans. Moreover, it has been pointed out that in many cases, folding of the lithosphere has taken place without any deposition of sediment, and therefore must have been due to other causes. Another common impression, as already mentioned, is that mountain formation has been due to the cooling and shrinking of the Earth. It was reasonable, perhaps, as long as the theory of the cooling of the Earth was unquestioned, to try to explain the origin of folded mountains in this way, for, of course, if the Earth shrank in size, even only slightly, as a result of cooling, some wrinkling of the lithosphere must be the result. The fact that the pattern of wrinkles that would be produced in this way, and which could be deduced fairly clearly, bore no resemblance whatever to the patterns of the existing mountain ranges, did not greatly diminish the currency of this theory, though it did bring about a devastating attack upon it by one competent geologist, Clarence Dutton. We have seen that there is now an impressive body of evidence and opinion against the theory of a molten origin for the Earth. The doubts that have gathered about this assumption are sufficiently serious to prevent us from basing any theory of mountain building upon it. Yeah, molten origin is, at least in the time of writing this book, was, yeah. But even if
I'm pretty sure I just watched a moon formation video from NASA.
Yeah.
With a giant molten Earth. being hit by another.
That wasn't the droplet that was molten. I mean, yes, the Earth, if it was hit by another planetoid, would have gotten really hot.
Yeah.
But that's not the origin of Earth. That's just early in its history.
Yeah. But yes, it would have been basically a molten ball at that point.
Yeah. So would the moon.
Yeah, it was. That's what it was in the video.
Yeah. Okay. So even if this were not the case, even if the molten origin of the Earth were a demonstrated fact, still, it was pointed out years ago by Dutton that the shrinking of the globe would not explain the folded mountains. Dutton had two objections. First, he said that the calculated amount of the shrinkage that could have occurred since the lithosphere was formed by the reduction of temperatures would not account for the volume of the mountains known to have existed during geological history. Secondly, he pointed out that the kinds of pressures that would exist in the lithosphere as a result of the shrinking of the Earth could not produce mountain ranges of the existing patterns. On this point, he said, as regards the second objection, which, if possible, is more cogent still, it may be remarked that the most striking features in the facts to be explained are the long, narrow tracts occupied by the belts of plicated strata and the approximate parallelism of their folds. These call for the action of some great horizontal force thrusting in one direction. Take, for example, the Appalachian system, stretching from Maine to Georgia. Here is a great belt of parallel synclinals and anticlinals with a persistent trend, and no rational inquirer can doubt that they have been puckered up by some vast force acting horizontally in a northwest and southeast direction. Doubtless, it is the most wonderful example of systematic plication in the world, but there are many others that indicate the operation of the same forces with the same broad characteristics. The particular characteristics with which we are concerned is that in each of these folded belts, the horizontal force has acted wholly or almost wholly in one direction, but the forces that would arise from a collapsing crust would act in every direction equally. There would be no determinate direction. In short, the process would not form long, narrow belts of parallel folds. As I have not time to discuss the hypothesis further, I dismiss it with the remark that it is quantitatively insufficient and qualitatively inapplicable. It is an explanation that explains nothing that we want to explain.
Wow. And he makes good points, though.
Yeah.
You'd have like some weird...
I don't have time to talk about this. It's bullshit. That's basically what he said at the end there.
Yeah, you'd probably have some more like...
yeah, I was thinking...
like a hexagonal pattern.
Right. I was thinking
you know?
the opposite of desiccation cracking. It would,
Yeah.
Right?
Yes.
Okay. So it is indeed astonishing to note that though a third of a century has passed since this statement was made, and though leading geophysicists today sustain Dutton's views, the impression is still widespread, and not merely among laymen, that mountains are more or less understandable as the consequence of the cooling of the Earth. The cause of this inertia is, very likely, the absence of any alternative, acceptable theory of mountain building. In recent years, many geologists have agreed with Dutton that the mountains were folded by some immense force operating horizontally on the lithosphere. Furthermore, they have come to recognize that the force or forces involved in mountain folding acted on the lithosphere as a whole and at the same time. Thus, one of our leading geophysicists, Dr. Walter Bucher of Columbia, remarked, taken in their entirety, the orogenic belts are the result of worldwide stresses that have acted on the crust as a whole. Certainly, the pattern of these belts is not what one would expect from wholly independent, purely local changes in the crust. The same thing was pointed out by Umgrove. But the growing amount of stratigraphic studies make it increasingly evident that the terrestrial crust was subjected to a periodically alternating increase and decrease of compression. I feel there is overwhelming evidence that the movements are the expression of a common, worldwide, active, and deep-seated cause. Umgrove was impressed by another characteristic of this worldwide force. It did not act continuously. It was not always acting to expand or squeeze sectors of the lithosphere to fold them into mountains. It acted only at certain times, and then, for other periods, it was inactive. There was a sort of periodicity to its operation. This periodicity extended also to other aspects of the Earth's geological history. So here he's quoting Umgrove again. The geologist comes across periodicity in many of the pages which he is arduously deciphering. In the sequence of the strata, for instance, and their contents of former organisms, he observes it elsewhere in the deep-seated forces that bring subsidence first in one area and then in another, in the intrusion of liquid melts or magma rising from some deeper part of the Earth's interior, in the rhythmical invasion of the continents by epicontinental seas and the subsequent retreat of the latter, and in the pulsation of climates, and in the rhythmical evolution of life. Let us note that Umgrove has here called attention to evidence suggesting a common causal factor acting upon A, the formation of successive sedimentary beds, B, changes in sea level, C, the intrusion of molten material into the lithosphere, D, the alternation of climates, including the occurrence of ice ages, E, the changes in forms of life, and F, mountain building. There have been numerous attempts to account for the observed geological periodicity, but they have come to nothing. Joly attempted to prove that the accumulation of radioactive heat in the Earth resulted in mountain building at intervals of 30 million years. Gutenberg, however, says that details of Joly's theory have been disproved, and moreover, that the theory includes no mechanism to account for the 30 million year intervals. It is impossible to see that the resulting upheaval of the surface could produce mountain ranges of the patterns that exist. Joly's theory does postulate a growing Earth, but whether the lithosphere bursts occasionally or is continually collapsing because of shrinking, it all amounts to the same thing. Neither theory meets the requirements. Attempts have also been made to explain periodicity as the result of long-range astronomical cycles, but they have been unsuccessful. It is obviously difficult to explain mountain building by astronomical cycles.
Really?
Yeah, that's why I wanted to stop there briefly. Like,
I mean,
can we explain mountain building by astronomical cycles?
if you don't include impacts, yeah, that would be tough.
But how would impacts cause mountains?
Through earthquakes, massive changes to the distribution of the crust. I don't know.
Yeah.
Introduction of new materials, shock waves, electric universe. Sorry, this is the first thing I thought of after I said shockwave.
Of course.
And yeah, I mean, it's like the surface of the planet is covered in astrobleams. So
Yeah. They usually flatten mountains, though. They don't make them.
I mean, but they shake shit up.
mean,
and if there's stresses already on the
I'm being facetious. Like, some of them are basically a giant circle of mountains.
yeah, yeah, but they're local. I'm just talking about like providing energy and resonance and all
Yeah.
that to kind of shake
Yeah.
things up and get things moving. But yeah, I guess you wouldn't say that was the cause, because if you went to a mountain range and it was like, okay, well there was a force coming from that direction that was pushing this way.
Yeah.
Where did that force come from?
Right. This massive lateral,
Yeah.
massive horizontal force.
Yeah, so it could have been started by a shock wave that was started by an impact or something like that as well.
Yeah. I mean, yeah. Yes. Yeah.
I don't know.
I think that's
That's the only thing I got for using cosmic cycles.
right. Well, I think that what he was talking about with astronomical cycles was things like the Milankovitch or,
Yeah.
the precession or axial nod, or Jupiter getting close, or something like that.
Yeah, I'm talking about like I've talked about like these thresholds that are reached. You know, like you have all these stresses and all these materials and all the forces of nature, gravity, inertia, all that stuff.
Yeah.
And they're, the hardness of materials are resisting the forces of motion and pressures and all of these things caused by gravity and whatnot. And then you have weather patterns on the surface that are moving oceans around, forming ice caps, draining, eroding stuff. And then eventually you have either a threshold is reached and something gives, like then you could have volcanism or whatever, then that changes the landscape because now you've got all these new pressures. You've got all this new material in places that it wasn't before.
Yeah.
So I
basically what you're saying is in some cases the situation may be that some area is just below the threshold of mountain building processes beginning.
Yeah.
And then all you need is like a bang from an impact.
Yeah, exactly. Shake it up
edge.
a little bit, and then everything starts moving, and then things start colliding, and then shit gets pushed up, and giant slabs get flipped over.
Yeah, it's like this spot's a mountain waiting to happen.
That's right. I don't know. That's just where my brain goes.
I mean, that's yes.
But it's like, well, is then that the cause of mountain building? No, it's a complex thing. It's right.
Yeah.
It's like, what is the cause of an ice age? Well, it's going to be
cold.
A lot of different factors.
Right.
What is the cause of the crustal shift if that's what does happen? Well, it's going to be a lot of factors. I guess that's what I'm kind of getting at.
Yeah. But what you're saying though is like if we're looking for a source of the energetic, of the energy necessary to start mountain building processes.
Yeah. I guess where he's going with this is that perhaps like the whole crust gets moving and then somewhere it drags to a stop for some reason. And then you've got the force of the inertia of the rest of the crust like pushing up against the part that stopped.
Yeah.
And then you can form mountains, and then on the other side it's pulling apart because this part stopped, this other part's still going, and so then it's creating a rift.
It's about the equatorial bulge. Any part of the lithosphere moving from the equator towards a pole during a shift is going to be compressed. And then anything moving from a pole towards the equator is going to be stretched.
Why do we have mountains down there then? At the equator. Should all be flat. With a bunch of rifts.
Because they get formed during a previous shift of that area towards a pole.
Yeah, and then they're not disturbed when they move down there. They're not pulled apart.
I don't know. I think the whole thing is supposed to move basically as one.
I mean, I can see that. You got a layer that flips up on top of another one, and then later on it moves down south or north to the equator, and then something else pulls apart, not the mountain range.
Yeah.
Yeah. So, okay. That's cool.
Okay. For some years, geologists have been looking for a mountain building force below the lithosphere. They have been investigating the possibility of the existence of currents in the semi-liquid layers underneath the lithosphere and speculating on the possible effects of such currents on the lithosphere itself. It has been suggested that such currents rising under the lithosphere or sinking might fold the lithosphere. A sinking current, for example, would have the effect of drawing the lithosphere together over it and pulling it down, forming wrinkles and long, narrow patterns like the mountain ranges.
Yeah.
Calculations have been made of the forces that could be brought to bear upon the lithosphere in this way. Somebody prefers this way of accounting for mountain building. If we examine the pattern of great geosynclines over the Earth's surface, we cannot doubt that their cause must have a worldwide character. The geology in these belts points to horizontal compression in the crust, at least during the latter stages of their development.
A syncline is like a... I'm thinking of it in a two-dimensional way, but it's like a rift almost, but it's just the sinking of the crust, but in a line, right? Like a whole line sinks down and makes like a trough.
Right. The two main hypotheses suggested to explain these great phenomena are 1, the thermal contraction hypothesis, and 2, the hypothesis of subcrustal current systems of such large horizontal dimensions that vertically they must involve at least a great part of the thickness of the mantle and probably the whole mantle. So, Campbell's theory of mountain building. James H. Campbell is responsible for the elaboration of a theory of mountain building based on the premise that the original active factor in the process is lithosphere displacement. We shall now examine his thoughts in detail. The reader will understand that in any displacement of the whole lithosphere, some areas must be shifted toward the equator and others simultaneously toward the poles. To be exact, 2/4 of the surface, diametrically opposite each other on the opposite sides of the Earth, must move equatorward, while the other 2/4 move poleward. This may be best visualized by looking at a globe, which we happen to have one handy here, thanks to Jeff. Since the Earth is oblate, a slightly flattened sphere, the parts of the surface that move equatorward will have to pass over the slight equatorial bulge, thereby being stretched, while those being displaced poleward will have to undergo an equal degree of compression or squeezing together, forming both synclines and anticlines. These deformations of the lithosphere may lead eventually, through the deposition of sediments and possibly through a number of successive displacements of the lithosphere, to the formation of folded mountain ranges. The systematic presentation of this theory requires us to consider the two different phases of displacement, equatorward and poleward, separately, for they have very different results. We will begin with the consideration of the effects of a displacement of a lithospheric sector toward the equator. In a shift in that direction, a lithospheric sector is submitted to tension or stretching, and this tension is relieved by the fracturing that takes place when the bursting stress exerted on the lithosphere has come to exceed the strength of the lithosphere. For Campbell's calculations of the quantity of the bursting stress as compared with estimates of lithospheric strength, he says see note 3. I shouldn't have marked that.
So is this how you get dikes?
Yes.
Okay.
He mentions this, that there are these massively long volcanic dikes where
full of basalt or whatever. Okay.
Exactly. Until fractures appear and multiply, the lithosphere cannot move over the bulge. After the fracturing permits the movement to begin, the lithospheric blocks tend to draw slightly apart. The spaces between them are immediately filled by molten material from below. So let us form a clear picture of this lithospheric stretching from the quantitative standpoint. It is important to estimate the stretch per mile if we are to visualize the results. Taking the globe as a whole, the difference between the polar and equatorial diameters is about 13 miles. Their circumferences, therefore, differ by about 39 miles. If the lithosphere were displaced so far that a point at a pole was displaced to the equator, the polar circumference would have to stretch 39 miles to fit over the equator. This would amount to about 9 feet per mile. Since the magnitude of displacements, however, according to evidence presented previously, seems to have been of the order of no more than about 30 degrees, or 1/3 of the distance from the pole to the equator, the average stretch per mile may have amounted to 3 feet, or about 1 foot in 2,000. So you're starting to get the picture. Yeah. So it is important to remember the nature of the lithosphere on which this tension is exerted. The lithosphere is comparatively rigid, having little elasticity, but it is not strong. It varies in thickness and strength from place to place. As we shall see, it is even now penetrated by great systems of deep fractures of unexplained origin. These inequalities of strength will be very important in determining the reactions of the lithosphere from place to the tension exerted upon it. They will determine the precise locations and, to some extent, the patterns of the fractures that will result. Without attempting to anticipate a more detailed discussion, to be introduced later, of the forces involved in this fracturing of the lithosphere, I would like to remark that the forces required for the fracturing are by no means so great as might be first supposed. It is a question of relatively slight forces exerted over considerable periods of time. All right, we are out of time. I could read this one more segment here, though. The time element is essential to visualizing the general process of a displacement. We have seen that the last one apparently took about 5,000 years. This means that this amount of time would be available for the creation of the system of fractures we are considering. It means, for example, that a single major fracture, which might involve, let us say, the pulling apart of the lithosphere to a distance of several miles and the filling up of the crack with molten material from below, might be formed over a period of several thousand years, during which time there might be spasmodically renewed earthquake fracturing and volcanic effects interrupted by periods of quiet. It is obvious that the amount of time available for the work of extension and fracturing of the lithosphere is sufficient to permit the process to complete itself without undue or incredible violence.
Working in that gradualism. He's got it in there.
Yeah.
But yeah, that's cool. I can see it doesn't have to be incredibly violent all the time, but
yeah.
There should be times of both, probably.
Yes, absolutely.
That's really cool. Cool stuff.
Yeah. All right.
All right.
Let's take
Last
a
break.
Yep.
Snake Bros Institute for Advanced Coprolite Studies. We return for the final segment. There are no degrees here, folks, only certificates of ignorance, which you have to print yourself or draw with a crayon or something. So yeah, kicking off the last segment here with some, do we have any ag updates? I don't know. I've been running around like crazy trying to button everything up before leaving for Egypt.
Yeah.
Making sure all the wine is stabilized, and
I'm doing that.
I've been over in West Cave.
That's right. You've been at West Cave working on the treb.
Yeah, you're doing it. I'm making sure that it's getting done. And, injecting some phosphorus and nitrogen into the vineyard.
Yep.
We did some soil samples, found out we had some deficiencies, and just remedied that. A good send-off for the vines before they go dormant.
Yep.
What else?
Ag-wise?
About to release a 2020 reserve wine. Did we talk about this already? We bottled it. It's delicious.
Yeah.
Amazing.
Yeah.
25 weeks in French oak barrels. Does wonders for a wine.
25 months.
25 months, I mean. Yeah, 25 weeks is not that great. It does wonders if you leave it in there for a lot longer than that. Yeah, 25 months.
Yeah.
So it's the longest barrel-aged wine we've ever made.
Mm-hmm.
Yeah, so I would like to be able to keep doing that, but, we have to keep releasing wine, so it's kind of hard to keep them that long, but I'm planning to age some of the 2021 stuff for a while. I don't know how long. I'm hoping to get away with at least 2 years,
Yeah,
for
some of the
it,
Monty
yeah.
or
Probably the same. It'll be the same deal. We'll make a gigantic blend.
oh, okay.
And then save
Save some of the some of the
4 or
blend.
5 barrels of it or something.
Yeah, okay.
So yeah, we'll see. But anyway, that's that. God dang it.
God dang. Yeah, and rock and roll. We got a show.
About to play a show on Saturday.
Saturday. It's coming up in a couple of days.
Vanderpalooza. It's a little kind of like a low-key, private sort of festival type thing for a bunch of. Really, it's Archer's friend group from Austin.
Yeah,
kind of like
yeah,
mostly them.
yep.
It's gonna be fun. Looking forward to it.
It is. Then we have. I got Space Brother news.
Yeah, let's
and then
do
we
that.
have
Do some emails after this.
spacebrother.com. Moon rocket update. NASA is going to host a media teleconference today to promise everybody that they will actually launch their rocket. That's not what it says. The agency continues to target November 14th. If the giant rocket takes off as planned, the mission would last 25 and a half days with a splashdown in the Pacific on Friday, December 9th. Also, there was an explosion of pink auroras. If you spend 10 years inside the Arctic Circle, you're going to see a lot of auroras. I have been guiding aurora tours for full time for the past 10 years, says Marcus of Norway. And I thought I had seen it all, but think again. We headed out early last night, November 2nd, to chase the lights, and what a surprise, he said.
Pink Marcus in the sky.
There were the most intense pink auroras I have ever seen. The pink color was bright and obvious to the naked eye. My entire group was stunned. Pink auroras are a sign of nitrogen. Should have gotten some of that for the vineyard.
Well, dang it.
Most auroras are green, the color of oxygen atoms being struck by energetic particles 100 kilometers to 300 kilometers above the Earth's surface. Pink appears when energetic particles from space descend lower than usual, striking nitrogen molecules at the 100-kilometer level and below.
Huh. Wonder why.
So what happened? Just before Marcus went out aurora hunting, a crack formed in the Earth's magnetic field. Energetic particles rushed through the gap, penetrating deeply enough for pink.
I wonder if the crack was moving towards the equator.
Equatorward.
It was moving equatorward. That's right.
Current conditions, solar wind speed is 528.1 kilometers per second. Density is 13.15 protons per cubic centimeter. Sunspot number is 49. The neutron count is 3.8% above the space age average. And the KP index is 3, which is quiet. 24-hour max was 4.
How long have we been in solar cycle 25? Do you know?
I mean, it's just starting.
I know. It's been a year or so. Couple years.
Yeah, I don't know. This says solar cycle 25 is beginning. And this is
yeah, but I mean, it's going to be beginning for years.
Yeah.
But it seems like it's probably been a couple years since
it
we
has.
started seeing.
It's reversed sunspots, right?
Yeah.
Sunspots with reverse polarity. Maybe we saw the first one of those a couple of years ago. I don't know. Yeah, I don't know. Good question.
No,
what about crypto?
I don't
See if I
know.
got crypto. Bitcoin. Yeah, Bitcoin is $20,325.90, and Ethereum is $1,551.94.
Still kind of hovering along right there.
It's just floating.
All right, shall we do emails?
Sure.
I probably have stories, but I'd rather do emails.
Okay.
I want to hear from these people.
Okay. This is from Jake. It's called Keep On Snakin', Path of the North Pole. Hey, bros. I just wanted to say the format change is great.
Aha! I knew it.
When you first tried it, I was like, what? But then I immediately understood. It's awesome getting down and dirty right away, then winding down with a friendly conversation and all the other stuff we listeners love. Well, thank you.
Appreciate that, buddy.
Also, Path of the Pole. I had no idea this had been studied, but I am so glad. I live in Canada and thought, Why are there no megaliths in Canada? It is a gigantic, verdant landscape with enough fresh water and wildlife for everyone. There's even megaliths in Siberia, so I thought maybe Canada was the North Pole. There's no megaliths here because it was covered in ice when the ancient masters were creating their titanic masterpieces in their butt flaps. If Canada was frozen, Siberia would be in a temperate zone. I did a couple of Google searches of the direction of travel of the pole, and it seems to be that indeed, yes, it has been moving north of Canada. Some skirp-charted results said no, it hasn't moved that much, but I think the consensus is yes, north of Canada. So, unfortunately, I guess I am stuck exploring craters, glacial erratics, and streamlined erosional residuals. Did I get that right, Randall? I live in Niagara Falls, and I always thought the impressive Niagara Gorge looked like it was carved much faster than what we're told, which is a couple of inches a year. Anyway, thanks for all you guys do. You're the best out there. Cheers from Jake. Oh, yes, and procession is excellent. Can't wait for the floppy disks. I don't care how much they cost.
All right. Appreciate that. They are coming. And by the way, Jake, no matter which way the pole is going, it's going north of Canada. Right? If it's going away from Canada, it's going north of Canada. That's right. It's weird to think of it as the pole moving.
Yeah.
Like when you think of the pole moving, it messes everything up.
Yes.
It's
that's right.
Yeah. But I know what you meant. I was not really nailing you for that. I'm just this is what my brain does when we talk about this kind of stuff. Like I think of this like, well, the pole has shifted this way, and then I'm like, wait a minute. No.
Well, I guess technically you'd have to say if it starts out as the pole, then the only direction it can go is south.
The pole always is moving south.
Yeah,
that's what I mean.
That's right.
But, yeah, it's easier when my brain tries to think of the pole moving, it breaks. It just stops. So I have to think of the crust sliding over.
That's right.
An imaginary point.
Yeah.
And no matter which way Canada is going, if it's going away from it, it's going south.
That's right. Which means the pole is going north. It can't not go north.
All right, next email. This is from Kyle. Wait, am I supposed to look? Oh my gosh, this is a book.
Yeah, I usually will like scroll down real quick to see what they call themselves.
Yeah, he called himself Kyle.
Yes, you're okay.
All right, bro. He says, Dear Snake Bros. Oh, it's called Path of the Pole.
Yeah.
He says, this is my first time reaching out to you guys as I initially told myself that I would get fully caught up with every episode before doing so. Have you read this already? I have failed tremendously. Oh, no. As I am nowhere close to having my brain expanded to its maximum capacity. Yet here I am typing out an email. I have been listening to new episodes and cherry-picking past ones that catch my interest as I have the time.
That's the way to do it.
I especially love how in-depth you guys go with these topics. The multi-episode book reports are phenomenal.
Thank you.
You have not gone the way of so many other mainstream podcasts that simply skim through a topic at a high level in order to fit it all in a single episode. You provide the thorough analysis from all sides that I so desperately crave when I research a topic, and you don't come at it as if you have all the answers. I found my way here by way of Ben at Uncharted X. Hey, what's up, old Ben?
I guess we'll have to tell Ben he got us another listener. Yeah. At least one
Thanks,
more.
buddy. Being an engineer myself previously, his focus on the technical engineering aspects of ancient sites really resonated with me. I agree, yeah.
Yeah. Yep.
Excuse me, folks. I'm sorry. I got the sinus problems right now. What Ben has compiled from all the work of Flinders Petrie and Christopher Dunn is fascinating. That, of course, led me to the work of Graham Hancock and Randall Carlson. Then to Cosmographia. The work you are doing with Randall is amazing. That man has so much knowledge that needs to be recorded and shared with the world. I want to lock him in a room and interrogate him until he has nothing left to say.
Wow. That escalated quickly.
If anyone actually did, his wise ass probably wouldn't say a damn thing.
That's
though.
right.
Yeah, yep. Anyway, the reason for writing this email is we haven't got there yet.
We haven't even gotten to the reason yet. Prologue over.
he says, the reason is your most recent book report on the path of the pole has me thinking quite a bit. If Hapgood's theory is correct, it would have major implications for how we look at climate, especially in how we interpret data of past climates. For example, most of what we currently think we know about past climatic conditions on the planet is coming from analysis of ice cores from Antarctica or Greenland. Could the ups and downs on a graph of the temperature be simply explained by the movement of that specific location relative to the pole?
Yes.
Very good. I like that. As far as I understand it, indicators of past climate are always specific to the physical location in which they are found. Interpretations of those indicators are interpreted as being indicative.
Stop using I words.
I'm sorry. This is funny. This is a great sentence right here. Interpretations of those indicators are interpreted as being indicative.
That's right.
Of the global climate. However, if the locations of land masses on the surface of the planet are moving around much faster than continental drift and in an unpredictable way, then doesn't that render any understanding of past climatic conditions at a global level utterly useless?
Yeah, I think that, was it part 3, maybe part 4? That was sort of what Hapgood was saying, was that the climate, you basically see it as bands.
Yes.
You know, there's climatic bands that are based on the tilt.
There are also rock bands.
Yes, they are ancient rock bands.
But yeah, he's drawing a connection here that wasn't explicitly stated.
That's right. Yeah, it's a good point that we are looking at, like, oh, look, you see global climate going up and down, these big fluctuations, but maybe it's just movements of the pole, and the climate has basically been stable relative to the axis of rotation.
Yes.
Yeah.
Great. Very good. So he continues, it's all built upon the assumption that the poles aren't moving relative to the continents except for continental drift. Is Earth's climate really changing significantly at all, or is that limited to effects caused by atmospheric composition and fluctuations in the sun? Why are we worried about this bullshit narrative of human-caused climate change of a few degrees rise in temperature if within 2 to 3 decades we could suddenly find the continental U.S. almost entirely within the Arctic Circle? Scientists should be trying to understand this because the implications could be severe, to say the least. Also, specific to explaining ice ages, I think crustal displacement has the answer. You have talked about the issues of needing greatly increased precipitation to generate all of that ice. Well, if the Earth's land masses are shifted all around, that would undoubtedly have a major effect on weather patterns. The atmospheric movements would remain relatively the same since that is caused by the rotation of the planet. However, the land masses and oceans are all in different orientations. I could see how certain orientations could lead to greatly increased precipitation rates in polar regions. Yep. That's a good point, too. Perhaps ice ages could be explained by the specific orientation of the crust to the poles, leading to weather patterns conducive to ice formation in the polar regions. I guess that's all I have to say about the matter for now, except for the 10 things I think of within 5 minutes of clicking send. On another note, I've been discussing with a colleague and friend about starting a podcast of our own. I work as a psychedelic integration coach, and the topic of psychedelics has all the ingredients for a great podcast.
Oh, yeah.
However, in my search for one, I have been extremely disappointed at the selection of podcasts out there having to do with this topic. Seems to be nothing but endless trip reports or doctors trying their very best to be semi-entertaining. I am fascinated by things such as the role psychedelics have played in ancient civilizations, the cumulative effect they have had on our human consciousness, the stoned ape theory, their influences on religion, etc., as well as how they can be used therapeutically or as a catalyst for self-growth and learning. I want to talk about all these cool facets of the topic and more, and inspire others to consider them as well. Any advice for a new podcaster would be greatly appreciated. The power that a podcast can have is immense, especially when done in a way that you guys have mastered. Thank you.
Thank you.
Inspiring people to wake up and approach the hard questions with an open mind to the unknown. This, my friends, is how you change the world, one mind at a time. Keep up the amazing work, and maybe we'll do a swapcast one day down the road. In health, Kyle. P.S. Will Marty ever get to the point? Or is he making the excruciating point that there is no point. Snakes! Oh, roasted Marty.
I
at the end
gotta
there.
roast Marty at the end there.
I don't know. We're going to find out because he's going to come back on the show and we'll see. But
Podcasting advice.
Yeah, make it easy.
Sit
That's my
down
advice.
and hit record.
Yeah, and make sure it's easy.
Yeah. I don't know what other advice to give. That's I like the learn as you go method.
Yeah. Start out being one of those podcasts that you don't like. And if you stick to it, maybe it'll be one that you really respect.
There you go. Did you unstar it? Is that what you did?
I didn't mean to.
Okay.
Is it gone?
I think so.
Whoops.
No, it doesn't matter. Okay, this is from Ron. Australites, for what it's worth, this is called. As a doctor, he says, according to the last listener communication episode, 262, I am inviting you guys to look into a 200-year-old mystery. As we know, there is a difference between fulgurites and tektites. I will not make this email into a book, but only want to bring a mystery to you and Kyle's attention, assuming that Russ has been volunteered to read all of the emails. I have attached a NASA technical note. Enjoy the read. I am partial to the last sentence of the first paragraph. Quote, the overall evidence establishes that the Australites are objects which have entered the Earth's atmosphere as individual pieces of rigid glass and have been shaped by severe aerodynamic heating, unquote. That being said, the other three tektite fields are far smaller, older, and have definitive craters. The Australasian strewn field is the youngest by far, 800,000 BCE, with no evident crater. As a side note, the chemical composition of these particular tektites do not have any correlation to anything in our solar system. Anyway, something to think about. I'm no Atlantean crystal ship theorist. Come on,
that's what I was gonna say. I was gonna say so. A crystal spaceship exploded. That's what you're saying.
I am the contrary to that hypothesis, but do find this Australite conundrum intriguing. Keep up the conversations. Without debate, nothing can be answered. From Ron. And then he does attach the paper, a NASA PDF.
That's cool.
Yeah,
Hey.
I agree. I think that's a great mystery.
Supports my theory, man. Carolina Bays could have been an impactor of some material that it's so similar to Earth that we just can't even, we're not recognizing it from digging. We're not finding the typical proxies.
Yeah. Yep. It is an interesting mystery. I agree. Okay. You want to read the one from Diona above this, and then and then we can finish with this one because this is the report from the geology conference.
Diona, that's a cool name.
Mama D, is that what it is? Yes, it's Mama D.
Mama D.
Yeah,
Mamad.
She wrote in complaining about the new format, but then she wrote this one.
Ooh. Look at the title. I'm getting a divorce. Is the title.
She's got the divvy papers. She's got her divvy papers.
Okay. First, this might be a novelle. Is that how you say that?
A novella?
A novella. A novella. I was thinking it was a novel.
Oh, yeah. It is a small novel.
A small novel. See? I don't know what's going on here. She says, but I have finally gotten my head and heart around the new format.
Yes.
Slither on. I still wake up listening to a random selection of Procession playing in my head. So Kyle and bandmates, well played, literally.
All right.
Thank you. So I'm dropping this note mostly to Kyle to tell you that I have also been waiting for a while for the next big drop or big thing, and I may not be around, at least in this form, for what's probably going to happen eventually. So what are you saying? That it's going to take us that long to make another album?
It's going to take another 20 years.
You might be right. Shit. So don't feel alone. But wouldn't it feel like some sort of approval or vindication? A huge cheer of, see, I told y'all it would happen. Splat, kaboom. I'm not sure what But anyway, she says, Randall and I are of similar age, and I really am becoming convinced that I need to get in on one of the excursions.
Oh, yeah.
If he can get out there and do it, I might could too. I've been on these paths before long. I've been on these paths before long ago, but had zero idea of what I was looking at. Absolute proof that the standard model fits like a bull in a handbag. The bull leaks out everywhere. Anyway, I want to see these things with my own eyes again with an open-headed, lighthearted, and interesting crew. The latest asteroid nudge made me scratch my head and wonder if, for the scientific community, that's the last we'll hear about it. Let's see. I think she's saying the last asteroid nudge made me scratch my head and wonder if, for the scientific community, that's the last we'll hear about it.
Yeah.
Anyway, she says, hey, at least we know how to measure and quantify solar storms and the magnetic outbursts. Ooh, pretty auroras. Another thing where Kyle and I agree. Let's see what a moderately destructive one would do to engage the problem solvers.
Is she talking about me?
I'm not sure.
Am I the one that was saying? I'm like, yeah. Well, let's get a little one. No, maybe that was.
No, I'm like, we just need one. Like a small disaster. That's yes. I get you.
Yeah.
So she says, okay, enough about this old gal. Keep on with these explorations. It's remarkably good stuff. All topics all around. Make more wine. Sing good songs. Find good, happy places. Always have, always will. Mama D.
Thank you.
Thank you so much.
Yeah.
That's very sweet.
So, yeah, I think maybe this sentence she was just saying the latest asteroid nudge made me scratch my head and wonder if, from the scientific community, that's the last we'll hear about it. Something like that.
I gotcha. Yeah.
Yeah.
Okay. I'm not. Yeah. You're better at this than me. Obviously.
No.
Yep.
Well, you need practice. This is what we do. Practice on air.
Well, I hope the next big drop you'll be around for that.
I think that is also, she's talking about a disaster. She's not talking about your album, I don't think. She's saying the big slam, the big drop, it's going to be the whatever catastrophe happens next.
Oh, geez.
Yeah.
I thought she was like,
she thinks it's
waiting
coming
for that next album to drop.
She thinks it's coming soon.
It's like, dude, we just dropped one.
Yeah, of course.
I'm dumb. Sorry.
Hey, it's a cold read.
I get it. Splat kaboom. Okay, now it all makes sense.
Yeah,
Jeez. Can I delete that and read this whole thing?
Yeah, if you want.
No, that's cool. Well, I'm sorry I butchered that. Mama D, thank you so much, though.
Okay, so this is from Green Man from the Discord. He went to a geology conference and he started talking about it in the Discord. And I was like, dude, can you write this up in an email? And he did. So this is fantastic. So I think we can finish out the show with this. Hi, Snake Bros. Sorry it took me a few days to send this. I've been pretty busy doing nothing. Rust asked if I could draft a summary of what I was rambling about on Discord, so here it is. I recently attended a large annual geology conference. Many of the talks I attended thematically align with topics from your show and Cosmographia. I am a geologist, but not really an expert on any of this. I went back and rewatched the talks online, but my commentary and summaries are only as good as my certificate of ignorance, which isn't even printed. Anyway, here are my takeaways from some talks. Abstracts to talks are linked. Impacts, airbursts, comets, and tektites. What I got out of several talks by Robert Harris and Stephen Jarrett is that interest in airbursts from comets is growing and being considered to explain glassy debris found in Earth's deserts. However, there was also an argument that much of the evidence used for airbursts over human sites isn't extraterrestrial or tektites. Basically, they don't think the site in Jordan was hit by a comet or asteroid or airbursts. They don't rule out the Vimana weapons, though. From what I can tell, the Australasian tektites, which is what the previous emailer was writing about, have no crater associated with them, despite their extremely large size and wide distribution. Michael Davies of Syntos.org thinks they are from a low-angle impact in the Michigan Basin, while it was covered in ice 780,000 years ago. Also, this created the Carolina Bays and other geological anomalies. I'll have to dig into this more in the future. There is this stuff called Edioe glass in Australia with a wild range of minerals that point to an extraterrestrial origin. A talk speculated that this may be from an airburst. Interestingly, they appear to have dates with big error bars around 700,000 years ago. The same guy presented on the Pika glass from a 12,000-year-old impact in the Atacama, which may have been from an airburst. He went over other possible candidates for airburst evidence in the geological record. Dakhla glass from Egypt and Libyan desert glass were named. Interestingly, this guy makes the point that averaging the flux of impact events doesn't account for clustered events that could create conditions of more frequent impacts, like comets or asteroids breaking up. He also mentions a 2007 impact in the Atacama where an old dude was 100 yards away from this impact and reported that it created a vertical vortex out of the impact. Luckily, he didn't have his pelvis broken and get frozen in place by frigid high-altitude air. So you see the connection there.
A reference to the mammoth.
Yeah. A vertical vortex created from the impact might bring really cold air down from the from high above. Okay, so then he provides all the relevant abstracts for that, and then he says White Sands footprints and timing of the ice-free corridor. From a talk by Benjamin Stoker on the timing of an ice-free corridor in the Laurentide and Cordilleran ice sheets. New beryllium-10 dates suggest ice was blocking a possible migration route at 13.5 thousand years ago. This means any sites dated older than the corridor opening were made by people who accessed the continent by some other path, which takes us to the White Sands footprints. The presentation on the human footprints found at White Sands by Jeff Pigatti seems to be a response to the criticism of the original dating presented in their paper published in Science last year, titled Evidence of Humans in North America During the Last Glacial Maximum. They used grass seeds from an aquatic plant for the carbon dates. They documented 2,000 years of human occupation between 21 and 23,000 years ago, and there was an audible gasp in the crowd when he said these dates. Critics claimed the older dates were caused by a hard water effect. This is caused by groundwater that incorporates carbon from older rocks in the aquifer, which can be absorbed by aquatic plants in lacustrine settings. This can screw up the carbon isotope ratios in the plant while it is growing.
Definitely never the problem when they want it to be really old.
Right. This can screw up the carbon isotope ratios in the plant while it is growing, so they aren't in equilibrium with the atmosphere, which is what you need for carbon dating to be accurate. To rule out the hard water effect, you can compare material like charcoal, which is assumed to not come from aquatic plants, and see if it matches the aquatic plant ages at the same depositional layer. They rely on a published work by another team in the same basin that uses this method to confirm hard water effects aren't screwing up dates in this local setting. They also argue their aquatic plants weren't growing in a deep lake, rather in small, shallow puddles, and the shallow water of these puddles would be in equilibrium with the atmosphere and its CO2. A third line of evidence they cite is the consistent and sequential dates they get from several layers they dated. Hard water effects generally cause huge fluctuations in dates, but the dates at this site have a very close grouping that gets older as you go deeper, which is what you'd expect if they aren't affected by hard water. This is a quote from their published response to critics. Quote, "They imply that the chronology at WHSA Locality 2 is problematic because it does not fit with previous paleogenetic estimates suggesting that human occupation of the Americas south of the ice sheets took place after 20,000 years ago, and that the initial occupations of other earlier archaeological sites in western North America were in the 18 to 15 Ka range. Those data are wholly independent of and unrelated to the findings at White Sands, which must be judged on their own scientific merit rather than whether they agree with prior findings. Instead, we suggest that researchers in archaeology and allied fields may need to re-examine existing hypotheses and the underlying data related to the peopling of the Americas in light of these new discoveries."
That's great.
Unquote. Additionally, I found it interesting that some of the human prints didn't have toes and looked quite like shoe prints rather than bare feet.
Yeah.
I know this doesn't mean they had shoes on, but it kind of looks that way to me. Screenshots are below. Unfortunately, there are no butt cheek impressions, so we cannot determine the advancement of their butt flap technology at this time. Thanks for creating such an amazing podcast and community. I can be found in the Discord. Sincerely, Greenman. And yes, he provided photos. I can put these in the show notes. These pictures of the footprints at White Sands. Really cool. And yeah, 2 of the photographs show what looks like shoed prints, and then there's one with definite bare feet.
Yeah, that's really awesome.
With children's footprints alongside of adults, it looks like. Thank you so much, man. What a great report. Really appreciate that.
So 21,000 years ago?
21 to 20, yeah.
Wow. 21,000
Which is too early
years.
for that the ice-free corridor, right? That thing was closed up. That's the whole problem that he was outlining there. Where is it? I lost it.
It's just interesting, synchronicity.
Yeah, so new dates suggest ice was blocking any possible migration routes by 13.5 thousand years ago.
Yeah.
And earlier. So if you're dating somebody's living in the Americas at 20,000 years, then they must have gotten here in some other way.
Yeah.
Or have been here a really long time.
Very cool stuff, yeah.
Yeah. All right, guys. That's it for this week.
Oh, we have producers.
Oh, yes, we do. We definitely do.
Pull up my producer sheet right here. We have two executive producers today. Number one is Ann Hunitz.
Ah, yes. And
she sent us $300. Thank you.
Thank you
so much.
Thank you.
And she says, if I say this is for Egypt, you will probably use it for pizza.
Man, pizza sounds really good right now.
Oh, you know us well, Ann. Thank you so much. Top executive producer of the day. And our second executive producer is Peter Beebee. And he doesn't leave a note, but $100. Thank you so much for that. And then we have associate executive producer Laura Coutu.
Oh, yeah.
I think that's how you pronounce it. I'm not sure, but $72.34.
Hey.
Thank you very much. And Bradley Justice, another associate executive producer, $66.60.
All right.
Sends us evil. Note.
Brad Justice.
And final associate executive producer is Douglas Obie. Thank you very much. $50.
Thank you.
Wow. They were just rolling in this week, man.
Yeah.
That's awesome. Really appreciate it.
Yes,
everybody.
definitely.
And yes, we are going to Egypt, and it is very helpful.
It is extremely helpful. We do use the value for value model. We call ours the pyramid scheme. So if you want to support the show, if you get any value out of it, you can support us through PayPal, like those one-time donations.
Send us straight to pyramids.
Send us straight to pyramids.
Or to a volcano.
Or a cave. Or any other place where we're going to look at interesting geology or weird ancient stuff. So you can support us through PayPal, one-time donations there, or Patreon. If you join the Patreon, there is Patreon content as well. So check that out. Sign up for Patreon. You can email us, brothersoftheserpent@gmail.com. Check out the website, brothersoftheserpent.com. That has all the podcast-related stuff there, including the way to support the show. How to get merchandise if you want merchandise, you want t-shirts or hats or stickers or magnets. If you like the show, give us reviews. It really does help if you give us reviews on iTunes. That does help spread the show. So, and thanks so much to all of you who have done that. You can also join the Discord. We have a chat, Snake Bros chat, Brothers of the Serpent chat on Discord. There's over 1,000 people in there. It's very active. It's a lot of fun. It's run by Jeff and a whole group of mods that have been there for a long time. So I really appreciate all the help from the mods and from Jeff. And yeah, check that out. You can get the link to it on the website as well. Anything else?
I think that's it.
Okay.
Just really appreciate everybody.
Yeah.
Appreciate you all being out there. We love you.
One more show before Egypt. And then after that, the content will be coming to you over YouTube as we, video stuff or whatever. But until we get back from Egypt, we won't be recording more shows after next week. So just heads up there. Well, yeah, we love you guys.
Always have.
Always will.
Good night, Adamu.
Get back to work.
That's right. That's right. Sew those butt flaps.